Hello, this is to explain some important information regarding the developed power system simulation package. Mainly, the software is developed in a Visual C# platform, and all the associated files inside the zip files are needed for the proper working of the software. Therefore, please save all the unzipped file in a single location. This software is mainly created for academic purposes to solve the power system textbook problems. We know most of the textbook problems, the data are given in per unit parameters, but if not, encourage the students or the users to per unit the given system by choosing proper base value, MV and voltage before entering the proper data in the software. The given problem is taken from the book Modern Power System Analysis, as shown in the bottom of this slide. The main aim of this problem is to find out the Ybus from the developed software. This is a 5-bus system, and all the values are given in per unit, so no need to per unit the system parameter. For Ybus formation, the software need both the branch and the transformer data. First, we enter the branch data, excluding the transformer data in the following format. Software format is as shown in the figure: from bus, to bus, resistance in per unit, X in per unit, and Y by 2 in per unit. Y by 2 means usually the shunt admittance have been lumped and divided into 2, represented by Y by 2 in the figure. For example, consider this branch. The element is connected between the buses 2 and 3. Therefore, from bus is 2 and the 2 bus is 3. In between, the branch resistance is 0.08 in per unit and 0.30 in per unit. Similarly, the shunt admittance is lumped and Y by 2 at both the ends, that is 0.25, and it is shown in the Y by 2 per unit in this table, 0.25. These all are the branch data to enter in the software. So this is the slide explaining how to enter the transformer data in the software. You can see in this table there is no from and to bus. Instead, there is ith bus, jth bus, and 2 more new terms A and B as shown in this table. We have 2 transformers in the figure, which is connected between the 4th bus and the 2nd bus, and the 3rd bus and the 5th bus. The software also has the provision to include the effect of phase shifting transformer. For that, some points to be remembered is represented by these figures. For example, any transformer in per unit is represented as 1:A plus JB. For example, if it is represented as 1:1.05 plus J.1, an arbitrary example is shown here, and one of the bus is connected to the first bus and the other end is connected to the second bus. Therefore, the one, please remember, the bus connected nearer to the winding represented by 1 is the ith bus, and the bus connected to the other winding represented by A plus JB, or in polar R angle theta, is the jth bus. Therefore, in this figure, ith bus is 1 because it is connected to the 1, and jth bus is 2 because it is connected to the winding 1.05 plus J.1. And this is A is here, the real part 1.05, and B is 0.1 here. Similarly, if the transformer is represented as 1:R angle theta or 1:1.05 angle 10 degree, the ith bus is 1 and jth bus is the winding connected to R angle theta, that is 2. And A is represented as 1.05 cos 10 converted into Cartesian, and B is equal to 1.05 sin 10. one more point to be remembered is the transformer is in the normal transformer 1:1. There is no magnitude or phase is not changed 1:1. There is no need to consider the ith bus as 1 or 2, and jth bus may be 2 or 1. No need to follow this convention, and A is equal to 1 here and B is equal to 0 here. Similarly, we enter all the data according to this. For example, if this is the transformer connected between 4 and 2, therefore 1 is connected to the fourth bus, therefore ith bus is 4, and 1.05 is connected to the second bus, therefore jth bus is 2, and R is 0 here, no R here, and X is 0.015 reactance of the transformer, per unit reactance of the transformer, and here Y by 2 is 0, and A is the real part 1.05, and B is, there is no imaginary part here, therefore B is 0 here. Similarly, the other transform is also entered. Finally, we got the final Ybus. It is a 5-bus system, therefore Ybus, the size of the Ybus is 5 into 5. This result is taken from the textbook. We want to verify this result with the developed software. Yeah, the next step is to enter the data in the software and thereby generate the Ybus of the considered example. So to start the software, click on the Ybus new file as shown in the file. So this is the interface first pop-up. So for Ybus formation, click on this button, Ybus formulation button. So first enter the branch data. For that, you click on this button. So this will appear. To add a row, click on the add a row button here to enter data. So now I am going to enter the data. From bus is 2, 3.08 resistance, 0.30 reactance, shunt admittance Y by 2 is 0.25, 1, 0.04, 0.25, 0.25. The next data is 3, 1, 0.10, 0.35, and there is no shunt admittance in that branch, therefore it is 0. So please avoid any row without entering any of the data, because if you do like that and if you click generate Ybus to generate the Ybus, it will show please fill all the data, and after that error will come. So to delete the row, please click on the delete select row, selecting this row and click on delete select row, remove that row. And now we finished the branch data entry. After that we go to enter transformer data. Here again add row, the two transformer are there, 4 and 2, ith bus is 4, jth bus is 2. All these are done with respect to the data entry rule we already explained. R is 0 here, per unit reactance is 0.015, 0. So A is 1.05 and B is 0. So add row, and again 5, 3, 0. Per unit reactance is 0.030, 0, 1.05, 0. Now we enter all the data, both branch data and transformer data. Now we want to generate the Ybus, so that please click the generate Ybus. The output format is Ybus in Cartesian forms. So this is the Ybus. The column entry and the row entry are shown, index are shown. And if you compare this data with the previous textbook example, it will very similar in value. So if you want the result is in polar form, click on previous page and change here in Ybus in polar form in this drop down menu, and again click on generate Ybus. So this is given the magnitude and the angle in degree are shown in this figure. So we got the final Ybus matrix in polar form and both Cartesian form. Thank you.